Welcome to Mechanics. This is Year 12 Mechanics, so this is now part of the course. It's compulsory for the A-level course now on the new spec. So I'm going to do about 15 videos on the Year 12 content to help you learn and become confident in the course. So before we get kind of started on some of the content of mechanics, I do need to go through some kind of terminology that comes up in mechanics. Because I'm going to be using these all the way through all questions and videos. Okay, so first of all, particle. Whenever you see a particle, it's a modelling word. You can model something as a particle. Mathematically, it's a zero-dimensional object. In other words, we don't care about its dimensions. Okay, so some things can be modelled as a particle, particularly if we're just interested in kind of seeing how things move over time, and the dimensions don't really have an effect on it. A rod or a beam is defined as a one-dimensional object, so we'll meet that in particular a lot in second year. A wire is a one-dimensional object that can bend, and sometimes you'll have a wire with a bead on it, but that tends to be in further maths. Laminar is a two-dimensional object, so a piece of paper or a piece of sheet metal or sheet plastic. Doesn't have to be a rectangle, it could be any shape. The word uniform, that will come up a fair bit. It just means the mass is distributed evenly throughout the object. So the centre of mass is right bang in the middle of the object. Okay, particularly important when we're dealing with rods and beams in second year when we're dealing with moments. The word light means that you can ignore the mass. The word heavy means you cannot ignore the mass. That's quite simple. Smooth means that you can ignore the friction, but rough means that you cannot ignore the friction. Okay, so friction will be present. And in second year, we will have a model for friction that we will come to learn and study. Then we have some objects. So the first object is what's called a pulley, and essentially it's a wheel with a string that goes over the top of the wheel. And we're going to look at this in first year, so a bit later on in this course. Look at the videos on that. But all pulleys on this course will be described as smooth and light. So smooth, ignore the friction, and light, ignore the mass. So the effect of it being smooth means that we can assume the tension is the same either side of the pulley, and that's important, and quite often a little one marker. Usually used in further maths, a bead is essentially a particle with a hole in it, so that it can go over a string or a wire. And then a peg, that is often depicted as a little triangle, but it's something that a beam will sit on. Something like that. Okay, so there we go, a beam sitting on two pegs, or if you like, it's kind of like a plank of wood raised up above the ground. You can kind of visualise it like that. And then two other things which we will need to be familiar with is the air resistance, which is essentially the friction of the air. It's the movement of the air particles that slow an object down. So that will come into modelling occasionally. And then gravity is taken as the value 9.8. And that's important because I know a lot of mathematicians will also do A-level physics. And in physics, you'll do 9.81, but you must use 9.8 in maths. If you use 9.81 in maths, you'll lose marks. And conversely, if you use 9.8 in physics, you'll lose marks there. So you've got to be really careful if you're doing maths and physics. You must use 9.8. And very rarely, but it can happen, a question could say, take G to be 10. That's just to help make the maths a bit easier. But unless otherwise stated, you use 9.8. Okay. So yeah, I started this a little bit dry, but you do need to be familiar with all of these words as they will come up in questions throughout the mechanics course. The other thing that you're going to need to be familiar with are the units. So there's something called SI units, which we tend to use as often as we can in mechanics. And we only really care about three base SI units, which are the mass, the length, and the time. So mass in kilograms, length in meters, and time in seconds. There are four other base SI units, which are temperature Kelvin, luminescence in candela, mole, which is some chemical thing, and I'm sure there's another one. I can't think of it right now. But these are the 3 that we use in mechanics. And then 3 other units that we use quite a lot are the speed or velocity, which is measured in meters per second, the acceleration of an object, which is a meters per second, or sometimes called a meters per second squared, and then the weight or force, which is measured in newtons, which as an SI unit is in base SI unit, is kilograms meters seconds to the -2, and that can be thought about as from Newton's second law, a force is the mass times the acceleration. Okay, so that's where that comes from. Okay, seem to be familiar with all these, if you aren't already. Slightly a bit dry, but that had to be done. So let's crack on with the course.